Hey, good morning, Dallas. Good morning, Las Vegas, and good morning, San Diego, to all the people, and also good afternoon and good evening. We don't know where all you are sitting and watching this show, but everyone, have a wonderful Friday. I could say that, and welcome to the Friday Talk Show with your host Rajiv Kulkarni on Global Electronics platform. Yes, we do this every Friday, and we bring in the industry experts in the electronics manufacturing, bringing every week a new topic to discuss, and people do ask questions. People do learn from this show, and that's our main idea of the show. And today we have a special guest with us. But before that, the topic is what is board level reliability test, why it is so important, and what does it do, what does it test, what are the main factors considered when designing a board level reliability plan. So there are numerous questions that comes into our mind when we talk about the PCB level, the board level, and also while designing the boards or designing the circuit, for instance, in the electronics manufacturing. So we have an industry expert today with us, and she is a senior staff packaging design engineer, I would say, and also she is a backend operation manager, works for pSemi, a company owned by Murata company, and they are in the RF IC design businesses. And her name is Mumtaz Bora, and she's also a SMTA board member. SMTA is Surface Mount Technology Association, as you all know, and she is the board member as well. So let's welcome Mumtaz Bora with us today to answer a few of your questions and also talk about this board level reliability test. Welcome to the show, Mumtaz. Good morning to you. I woke you up pretty early this morning, but with the wealth of knowledge you have in the RF, board level reliability test and other things. So I think it is definitely worthwhile to share with our audience, and they are very, very eagerly, are looking forward to, your input about that. Welcome to the show.
Thank you, Rajiv. Thank you for the opportunity. And
Absolutely.
thank you, everyone, for joining. My name is Mumtaz Bora. I'm a packaging engineer and a backend operations manager at pSemi. We are a manufacturer of RFIC packages, and our packages go in many different applications, one of which is mobile wireless. And the customers in mobile wireless require us to do board level reliability testing. Typically, for component manufacturers, we conduct the testing per JEDEC, and it is only done at the component level. But to ensure further reliability in the field, our customers are requiring us now to mount the components on the board, run them through one heat cycle of reflow, and then test them. So it gives them a better assurance of how they will survive after assembly. So that's the intent of doing board level reliability testing.
Wow. That's just amazing, and I'm pretty sure that board level reliability test being conducted by pretty much all the electronics manufacturers. Is that a correct statement?
Yes, currently it is more customer driven, but I think as we go along, more and more complexity comes into the packaging and assembly. I think it will become more standard test rather than just the component level testing done per JEDEC specs.
Okay. And is it because of the robust board design and fabrication, which has a multiplier effect, right?
Yes, it
Uh,
does
uh,
have a multiplier effect. Sometimes you will see that components are intact, but board traces are cracking. And sometimes you will see that the bumps are cracking and the packages are cracking. So, yeah, so by assembling, we get a better perspective of what that reliability will be when it goes in the field.
Okay, okay, very interesting. So I have a few questions which has been raised, by some people that when we circulate this. So, ladies and gentlemen, Global Electronics platform, this podcast platform that we bring in every Friday to introduce different topics in the electronics manufacturing. Today we are talking about board level reliability test plans, and the question is, with SOCs and SIPs and heterogeneous integration board design and performance matrices are percolating towards IC packaging workflows. Do you agree a thin line delineates chip packaging and board design and packaging? Do you agree?
Yes, I agree. Certainly the gap is getting narrower and narrower.
Okay.
And so we need to have synergism and collaboration in how we do designs and how we do the testing and the assembly, so that end customer gets the level of reliability that they are looking for.
Wow. Wow. So, um, on your end, especially there is also like off-late chip design rules are getting into HDI and ultra HDI design rules, and it does bring semiconductor-like discipline into PCB layout, right? So, what is your message to the PCB design audience? Because that is one of the key and very important factor before any circuits takes off.
Correct. Yes, that is very true and very real. Uh, as the nodes get tighter and tighter
Uh-huh.
at the silicon level, and we go to tighter and tighter pitch on components. So currently surface mount industry is successfully doing 0.4 millimeter pitch in HVM. Now our customers are requiring us to go to 0.3 millimeter pitch and further. And at the same time, a lot of integration is happening at the silicon level. So things are getting finer and tighter. So from the design standpoint for PCB, yes, we have to prepare for fine traces, fine spaces. We are going to ultra HDI. In the packaging substrates, we have already gone to ultra HDI, 2 mil lines, 2 mil spaces, going into 1 mil line and 1 mil space. Finer and finer vias, 30 micron, 40 micron. So yes, so the designers have to learn to align to what the needs are of the industry are, and prepare to design in that form, and also to keep in perspective design for manufacturability, design for reliability, design for environment. All these things are becoming more and more critical as we approach future designs.
Okay, okay, very interesting. And what do you think, what are the main factors that needs to be considered when designing a board level reliability plan?
When we design for board level reliability, yes, we have to keep in perspective what packages we are going to solder on it, and what type of reliability we are looking for. So a collaborative approach will be much better, where we have an understanding of the end product and then design for it, rather than design and then test and find out that it is not working and then have to redesign. So
So collaborative is basically you're saying that with the suppliers and the
the
manufacturers,
users, yeah.
users. Okay, okay.
Yeah.
Yeah, that is very true. That is very true. And I know. I mean, there is one question. What exactly? Of course, I don't know if you mentioned that in the beginning. Board level reliability test is basically the components we are going to test, right? So,
Yes.
so I mean, that's what the question is. What does it test basically? What does board level reliability test means? So,
So board level reliability, yes. So if you just take a component and test it for the JEDEC standards for thermal cycling, temperature, humidity, high temperature storage, you have tested it without putting it through a heat cycle.
mm-hmm.
So
Okay.
by soldering it on the board and then testing it, you have put it through some more heat
Heat. Yeah.
impact, and then see how well that survives. Most of the time when users get components, uh, even though they pass JEDEC test, sometimes when they solder and they go in the field, they do not work. So
Okay.
it's important for them. It is important to have this reflow and assembly data before they receive the parts.
Okay.
So that way they have confidence that it survived the reflow.
Okay, interesting. So, ladies and gentlemen, let's take a quick, small commercial break here, and then we'll come back after this break. Okay, I think we have a small glitch here. So, welcome back to the show again, Mumtaz. So, now we have very valid points that we spoke about the board level reliability plan, but now there are like many technology association, technology bodies. They are engaged on a day-to-day level of whether it's a reliability test, whether it's processes, whether it's the standard operating procedures, the process activities. So, what are the key role of the industry bodies like IPC or IEEE, of course SMTA for that matter, on a large scale system level reliability?
So yes, so a lot of collaboration will be needed in the professional societies to bring the synergism between board, assembly, and silicon and components.
Okay.
So today we are doing individual standards as IPC, as IEEE, as but I think in the future we may have to collaborate on the standards, because as we go into multi-chip modules, as we go into heterogeneous integration, multiple dies, multiple functions, and multiple substrates are involved. So I think the standards will have to have a different approach than what we have today to make sure that the needs of the reliability are met using those standards.
I know that you mentioned about JDEC standards, and does IPC has certain standards on the board level reliability test?
So yes, IPC has a 9701 series of standards.
Okay.
They are for board level reliability.
Okay.
They are for monotonic band, mechanical shock. Several standards have already come out for board level reliability. JEDEX typically is a component standards body.
Okay.
And we go to IPC for assembly and board level standards. And the silicon standards, some of them come from the SEMI.
Okay.
So in the future when we have multiple dies, multiple different board designs and all, I think there may be some collaboration needed at that point to get out meaningful standards that will work, that can be applied for accept reject criteria, for testing, things like that.
Okay. Excellent. And what is the normal like procedure for a board level reliability test if somebody has to do that? Like probably how many processes involved, or is it depending on what kind of test that particular manufacturer would like to conduct, or there are certain like defined processes that these needs to be done and these are going to take so many days and so on and so forth. So if you can give some overview on that.
Sure. So currently it's more customized. It's more driven by customer.
Okay.
They typically define what testing needs to be done.
Okay.
And suppliers have to conduct that for lot acceptance. But there are, we as component manufacturers are also looking on our own to conduct board level reliability testing, so we can have a better feel for how the component survives in the field. So typical tests for component are thermal cycling, thermal shock, and temperature humidity, and high temperature storage. But we have not been doing too many of the mechanical tests,
Okay. Is that
but in the mobile wireless industry,
Yeah. Is there
We
a
need to
particular
do.
reason that why we are not doing so many mechanical tests?
Uh, Typically, yeah, we have not been doing it mainly because they were not customer required. But
Okay.
now, since the applications are becoming different and
Yeah.
more mobile, it's required. So now it is important to learn, mechanical shock testing, monotonic band testing. Before we were just doing cell phone drop test, you
Yeah.
know, and providing the data. But now I think other forms of testing are becoming more prevalent, and they are needed for assurance of field survival.
Okay. Excellent. Excellent. Very good. So I think there are a lot of these questions which have been addressed very effectively by you, looks like. And is there anything else you want to add, Mumtaz?
I would like to say that yes, the industry is going to tighter and tighter nodes, and finer and finer pitch. So we all need to keep things in perspective and collaborate, and keep design, keep fabrication, keep testing and reliability in perspective, so that we can have more success in the industry.
Excellent. And thank you very much for that lovely message. Ladies and gentlemen, today we have Mumtaz Bora, who is a senior staff IC packaging engineer and also backend operation manager for pSemi, which is a Murata company who are engaged in the RFIC design packaging materials, and they are into the components as she mentioned already, and she has this expertise of board level reliability test, and as you heard from her itself, very crisp and very clear answers she had given for the questions raised by certain people. And moreover, Mumtaz is also available for any further details, further discussion you would like to have. Of course, her contacts are displayed in our presentation, which was shared by her, and you can also go through those displays and the presentation, which will be available on the link of this particular show later date also when you watch this show. Thank you very much, Mumtaz, for joining us today this early morning. Ladies and gentlemen, she lives in San Diego Pacific time. It's 6:47 a.m. right now there, as well as I am based right now today in Las Vegas, attending the Consumer Electronics Show, which is mind-boggling and mind-blowing, I would say. Looking at the technology, as Mumtaz mentioned, that these days the circuits have become so intense and very dense, and because of that, the mechanical tests which were not being conducted so regularly will be considered to conduct on the reliability front, because of there's a fear of always stress coming onto the components, because the circuits are getting smaller and smaller and very dense, and because a lot of power and a lot of intelligent chips being imposed on the boards. So because of that, a lot of signals being exchanged between the receiver and the transmitter, and the power handling capacity starts going up and up, and because of that the circuit can damage. So that is why you need the board level RF design reliability test for sure. So I think this is a very interesting topic, and if people have any questions, you can always put in our YouTube link, and that we will address it to Mumtaz, and she can definitely come back with the beautiful answers for you all. So anything else, Mumtaz, before we say we end the episode today?
So yeah, what I wanted to mention was board level reliability testing was done for certain applications like Hi-Rel, space, defense. In some of those areas we had to do it, but we were not doing it so much in consumer products.
Consumer,
So
yes.
now we are initiating that.
Yeah. Yeah, because the
Based on the
consumer.
learning in the industry, I think they think that by doing board level reliability testing, they can get a better perspective of
Yeah.
how packages will survive in the field.
In the field, correct. Yeah, because the consumer electronics also, if you look at the gadgets are becoming so small and very smart as well, and I think the circuits are getting so dense, and definitely I think these kind of tests are, needed, so that the circuit doesn't get damaged or affected in the field. Okay.
And also, automotive has also come up with the board level reliability testing now.
Yeah, I
So
thought
they've also added that.
But I thought automotive already had before. Didn't they have before?
They had testing for the AEC-Q 100 standard, but now
Okay.
they have added AEC-Q 007, specific for board level reliability testing.
Okay. So this is for any automotive electronics as far as is concerned.
Yes,
Okay.
correct. They have defined their own separate spec.
Okay.
Even though
So-
IPC has one, they have their own spec now for automotive.
So that is a part of the PPAP evaluation process.
No, it's part of their reliability testing process. Yeah.
Okay, it's part of
Yeah.
the relab. Okay, excellent. So what about on the aerospace aviation industry that you are there like certain standards being defined on the board level reliability?
They are mainly based on the MIL standards.
Okay,
So MIL standards currently, I don't believe they have.
okay,
But it has been done customer specific. If customer required, we had to do it.
okay. And in the board level, you also mentioned the thermal cycling test is being conducted.
Yes.
Okay. And is that something to do with the thermal material being induced in that during that time, or how?
To see how the CTE mismatches
Okay.
affect the component pins and
Okay.
impact the cracking.
Okay. Very interesting. So the more and more we keep talking, I think there are so many questions keep arising, and it's a never-ending process. And we are almost coming to the end of the show. Another 5 minutes we have. So I think thank you very much, Mumtaz, for your time this morning. It was very nice to speak with you, to learn from you, and get this in-depth knowledge of yours to our audience. And I hope everybody definitely would enjoy this show. And please do comment on the comment section on our channel, and please do subscribe our channel to bring more and more expertise like Mumtaz Bora on our channel. Thank you again. With that said, thank you for joining, and wherever you are, please do take care. And of course, in the US, we are getting very cold weather front here, and so stay warm and stay safe. With that said, your host Raju Kulkarni will take leave this episode of another Global Electronics Friday talk show, and we will see you next week again at the same time with another topic, which is again very interesting. We are talking about the stencils in the SMT manufacturing, in the electronics manufacturing, how important it is to have stencils in the PCB assembly activities. With that said, thank you again, and you take care, all of you.
Thank you, Rajiv, and thank you, everyone. Appreciate
Thank you,
your
ma'am.
presence.
Thank you. Thank you, Sandeep, for always supporting A&V perspective. And we'll see you next week at the same time.
Thank you, Sandeep. Yeah.